Supply Network Dynamics Chapter 13 Part 6, Leverage Points, where to intervene in a supply network. So we've seen all these business tsunami, and we've seen that management of these supply networks typically has problems in dealing with them fast enough, making sense of them fast enough, deciding fast and effectively enough, implementing the changes to be made fast enough, and learning from them fast enough. But what are then good decisions to make? What are then good implementation policies? And this is very difficult to answer in a specific sense. What I hope you have learned, and I keep on learning by now, is that you need to have a pretty thorough, in-depth understanding of the structures that lead to the dynamics that we see. And then, when you understand the structures, you can do something sensible. Somebody who was extremely thoughtful about what sensible things are to do in order to change the system was Donella Meadows. Unfortunately, she passed away prematurely. But one of her many thought-provoking essays was one on leverage points and on different degrees, different depths of leverage points. Now, the notion of leverage point, where you actually have a lever so you can actually pull something up, is pretty fundamental for system thinkers, for system dynamicists, for systems analysts in general. The idea that with a very precise small intervention you can have a very big impact. The silver bullet, the tipping point, the magic touch, whatever, that idea. And there are real leverage points in real world policy problems. The problem is that they're often highly counterintuitive. In fact, one of the quotes of Jay Forrester is that people generally know about leverage points in their organization, only they keep pushing them in the wrong direction. And here are a couple of examples from Forrester's own work, as quoted by Donella Meadows. From industrial dynamics, we know the problem was the oscillation. The fact that the factories sometimes had to work overtime, other times were very much underutilized, whereas in retail there was not a lot of difference. And the temptation is to make everything, the adjustments in inventory, then faster. The problem is when you do that, actually you increase the oscillation, you get greater fluctuations. So yes, the delays of adjustments are very crucial, but the very good policy is to make those delays longer rather than shorter. But it is a leverage point. In the world dynamics model, the Club of Rome models about world population growth, the mantra is more or less growth. Growth is good. Growth keeps economic growth. But one of the, and so everybody's promoting, economists and demographics and politicians side by side, more growth. The problem with more growth in a finite world is that more growth leads to more pollution, leads to more poverty, leads to more wars, etc. The leverage point is indeed the growth of the population, but it's better to have less growth. In fact, no growth at all of the population. That way there's more to share. In urban dynamics, just 8 years later, the dominant, that there was lots of crime and poverty in inner cities in the US, and the solution was to provide low-income housing for all these poor people in the inner cities. And what Forrester showed was that it actually leads to more poverty and more crime in those same inner cities, because it makes it difficult for new activities to come about in those same inner cities, and all the economic activity goes outside of the cities. That was a very controversial thought at the time. Forrester was ridiculed, but by now all those projects from the 1970s and 80s have been demolished in the US as well as in Europe. And we now know that you need more diversity in the inner cities. So again, a leverage point, again very counterintuitive. And this is the Donella Meadows list. It starts with 12 as being the least effective way of intervening and ends with 1 being the deepest. And it's fair to say that the majority of the examples that we've been looking at in these chapters of supply network dynamics is around the top 4 or 5. Hardly ever do we change the structure of the information flows every now and again. It's mostly in the top area. And in Danella's list, that's the least effective one. So she's right. Although, no, she's right, period. Nevertheless, there's a lot to be gained already from changing some of the first ones. But the deeper that you come, the more difficult it becomes to implement them, but also the more fundamental the impact is. Let's look at them one by one. So the majority of changes that we've been looking at in this course is changes in constants, parameters, and numbers. Just to give you an example, this is the screen, the experiment screen from the sim for chapter 4, the semiconductor industry, and here you see those parameters. Do we allow a smaller maximum workbook? And then you see that actually things get better. Should we have the target capacity utilization lower, and what does it change? And then of course in an economics and in terms of your whether or not you make a short-term profit, these things make a huge difference. But in terms of the behavior of the system, they don't change all that much, those maximum parameters. And that's then immediately the problem that we have with these subsidies, taxes, standards. We have a VAT now in Holland of 21%. We used to have 90%. Any change? Well, yes, to the national income, or at least to the government's income, there is, but not to the way that our system works. So those, and the vast majority of discussion is about that, about how high a certain tax should be, how high a certain subsidy should be, how fast we can now travel 130 kilometers somewhere in Holland on the highways rather than 120. Does it change anything? No, it doesn't change anything in congestion, not significantly, or in pollution, marginally, but there's a lot of discussion around it. Slightly more, if you do have to change the constant, then one of the suggestions that Danella Meadows has was the size of buffers. Take rivers. Rivers have a small buffer of water, but they can flood easily. Lakes don't flood that easily because there's such a vast amount in there already. If you can change the size of buffers, then you can stabilize stuff. Well, I had in chapter 9, we had the example of the pooling, so that the call centers could be more stable. So have a quicker, so that you can fluctuate easier in the call centers. You could change in chapter 4 the size of the buffer inventory and see what it would do. So we have a final inventory here, which initially is set as the target stock. If you make that 10 times the target stock, I'm sure something will change. I'm not sure how much will change, but let's see what it does. And we can have some revised assumptions. Well, the only thing that I see is that you have a bigger stock of finished products here, but there is a peak, although it will have some impact. Again, you can change these numbers, but if the underlying, what we believe is system dynamics, is that it's the loops that drive behavior, and unless you change the loops, nothing much will change there. The structure of the material stocks and the flows, yes, of course, if you have no final inventory, it will change. If you have an extra stage of finished planes, for instance, all sorts of that kind of the stocks and flow stuff, yes, that will change the behavior significantly, because then you start changing the plumbing. Even more in depth if you start changing the length of the delays. That also has, there are a few capacity adjustment delays here. There's production planning delays, the capacity acquisition delays. If you start changing these, yes, then you get a much more significantly different behavior, because that's almost like changing the rules of the game. At least the degree of oscillation becomes much more prominent then. So these are the modest impact policies. The more medium-sized impact are if you actually start playing with loops. And the loops always have to do with the informational parts of the system, where you change the way that information is used. Take, for instance, the strength of negative feedback loops, of the corrective feedback loops. We saw that if you have a quicker feedback in Chapter 5 between the information of the supplier has of the final demand of the OEM, that actually the capacity adjustment there is a lot faster. So yes, that's definitely a lot. The example that Danella Mellows mentions here is preventive medicine, exercise, good nutrition. So preventing illness rather than trying to overcome illnesses is a big trend. Preventive medicine nowadays also. We see that most of the health gains are there. Integrated pest management, so natural predators, crop pests, etc., rather than all sorts of fertilizers or toxic materials. Freedom of Information Act in a total different area. Environmental damage monitoring systems like the ones that monitor the ozone layer. Protection for whistleblowers, still a difficult issue. Pollution taxes, etc., so that you can capture the externalized public costs of private benefits. You see, Donella Meadows is one of the environment and national policy, not so much of business. But those are negative feedback loops that are then strengthened. So the negative feedback loops work correctively. If you can make them stronger, yes, that will have a significant bigger feedback effect. The same with positive feedback loops. So we saw that there is a positive feedback loops in Chapter 5 between the amount of the degree of stress on the production system and therefore also the lead time and the customer base knowing of this, because the more that they know, the more likely they are, the sooner they know, the sooner they are likely to order and therefore increase the stress on the system. If you can make that less prominent, as we saw also in the sim, by delaying that information, the positive feedback loop becomes less active. The structure of the information flow, who does what and who does have action to the information, is also a very important driver, even fundamentally so. If you would have many of the tsunami notions are of this nature, if you would know earlier what was coming towards you, you would act sooner and you might even prevent the entire problem. So that's the medium impact. And then you have the high impact system policies, and there are not that many examples of this in our course, but of course if you change the rules of the games, or if you even change, if you can make the system structure self-organizing so that it adapts automatically to changes, if you can change the goals of the system, yes, then you would have a very high impact. Indeed, this becomes more about politics and philosophy and biology and ecology, and at the deepest level, the paradigm shifts. The mindset of the paradigm out of which the system arises, yes, that would make a real difference. So if we go back to Chapter 4, if you go to the mole equations there, we have the production capacity, which is part of a loop. If you simply say, you know what, the capacity change rate, forget about all the other things. Let's just say it's all this is 0, and it's simply 10% of the current capacity. Then probably that would be 10% times the capacity available. That would probably be a much bigger impact than anything else. Let's see what it does. Everything changes if you do it like that, because here's the capacity available. You would still have some some changes in the, let's run it a bit longer. Sorry, run specs. Let's run this for 100 months. And you start seeing a very stable situation with a very stable order fulfillment rate and more capacity available. Not sure, but of course the order intake stays stable in this model. Anyway, the changes in this way become much more fundamental, but of course we don't do that. We don't cheat, as is to say, by changing the model equations. We ask you to stay neatly within the slider bars that we specify, but those are the real paradigm shifts. So if a semiconductor business would say, you know what, we just add 10% capacity every year, regardless of the business conditions, that would actually get a lot of the oscillation and a lot of the volatility out of the system. But we don't, because that's not the way our business works, because that would mean that you would lose money. And the most fundamental one is the power to transcend paradigms. So if a paradigm is a way that you look at the world, if we could switch between those depending on the appropriateness for the condition, that would even be marvelous. But I don't think I can do that myself, because as we all are, I'm also locked in the paradigms that I hold high, and find it difficult to see other paradigms. Yeah, so those are all those different interventions. And I'm already happy if we start doing the first 4 or 5 much more based on a systemic understanding. I suppose the bottom line then becomes that here's one paradigm that I think that I also learned from Danella Meadows. The paradigm is that I'm a little individual, what difference can I make? And her point is every individual can make a difference. Now there's a paradigm shift. And perhaps, and hopefully, some of you will get inspired by this course and try to make as an individual the difference. And that will make all the difference.